An explosion breaks a rock into 3 parts in a horizontal plane. 2 of them go off at right angles to each other. The first part of mass 1 kg moves with a speed of 12 meter per second, and the second part of mass 2 kg moves with the speed 8 meter per second. If the third part flies off with the speed 4 meter per second, then what is its mass? To solve this problem, we need to apply the principle of conservation of momentum. Since the rock explodes, the total initial momentum of the rock was 0. Therefore, the vector sum of the momenta of the 3 pieces after the explosion must also be 0. Given the mass of the first part m1 is equal to 1 kg, velocity of the first part v1 is equal to 12 meter per second, mass of the second part m2 is equal to 2 kg, velocity of the second part v2 is equal to 8 meter per second, and speed of the third part v3 is equal to 4 meter per second, and we need to find what is mass of the third part m3. The first and second parts move at right angles to each other. Let us first calculate the momentum of the first two parts. The momentum of each part is given by momentum is equal to mass into velocity. Momentum of the first part is nothing but P1. P1 is equal to m1 v1, which is equal to 1 into 12. We get 12 kg meter per second. And finding momentum of second part P2 is equal to m2 v2 is equal to 2 into 8. We get 16 kg meter per second. Since these two parts move at right angles, the resultant momentum of these two parts can be found by using Pythagorean theorem. Therefore, P resultant is equal to square root of P1 square plus P2 square. Substituting the values of P1 and P2, we get P resultant as square root of 12 square plus 16 square, that is nothing but 20 kg meter per second. Since the total momentum of the system must be 0, the third part must have a momentum equal in magnitude and opposite in direction to the resultant momentum of the first two parts. Therefore, momentum of the third part P3 is equal to 20 kg meter per second. Using the relation P3 is equal to m3 v3, we can solve for m3. m3 is nothing but P3 by V3, that is equal to 20 by 4, which is nothing but 5. Therefore, the mass of the third part is 5 kg, and the correct answer is option A.